Today I'd like to look at a proof for this fundamental exponential limit here. And there are going to be two parts to this. We're going to start with looking at this definition of e and reworking it a bit, and then we're going to look at this limit itself and evaluate it. So let's start over here. Hopefully you're familiar with this, but the limit as n approaches infinity of 1 plus 1 over n to the power of n is one way that we can define e. Working from this, let's take a new variable, maybe z, and we'll set it to equal 1 over n. And now let's try to get this whole limit in terms of our new variable z. So this part is nice, we can just replace that. We also need to get n in terms of z. So multiplying both sides by n and dividing both sides by z is going to get us n equals 1 over z. Now we can replace this here. And the last thing we need to replace is this limit. As n approaches infinity, well, we have to figure out what z approaches. So, using this right here, if we're thinking n is approaching infinity for 1 over n, what is z going to approach? Well, it should approach 0. If you think of 1 over a really, really large number, it's going to be really, really close to 0. So let's rewrite this whole thing. Down here, we have the limit as z approaches 0 of 1 plus z to the power of 1 over z. And that will be the new definition for e that we will use later on in this proof. So, part 1 done. Now let's take a look at this limit itself. And I'll just copy it out over here. We're taking the limit as x approaches 0 of e to the x minus 1 over x. And we're going to start right away with another substitution. This time let's use the variable t, let's say, and we'll set it to this numerator here. E to the x minus 1. And again, just like we did here, we're going to get the whole limit expression in terms of our new variable t. So this part's easy. We already have that done. We're calling this t, but we need to figure out what x is on its own. So let's isolate for x. I'm going to add 1 to both sides, so we get e to the x equals t plus 1. Take the natural log of both sides, just like that, and ln e to the x is just going to be x equals ln t plus 1. So there's our x that we can plug in for the denominator, and like before, we also need to worry about that limit. What happens to t if x is approaching 0? So it's going to be easiest to look at this one right here. And there's nothing wrong with just plugging in 0 for x. E to the power of 0 is 1, minus 1 is 0. So as x gets close to 0, t will also get close to 0. So that makes our life a little easier. It's just the same limit as now t approaches 0 of, we called this t, over ln t plus 1. ln t plus 1. Okay, next up we're going to put this down into the denominator and flipped. So we're going to write it as the limit as t approaches 0 of 1 over t to the ln t plus 1. And if you were to think about putting this back in the numerator, you would have to be multiplying by the reciprocal, so it would go back to the t being normal in the numerator there. So we didn't really change anything. And now with property of logarithms, which the natural log would fall into, we can take this coefficient, I suppose it's not really, but we can bring that into the exponent here. Usually you're going the other way, you're dropping the exponent down in front, but here we're going to go backwards. So we're going to get the limit as t approaches 0 of 1 over ln t plus 1 to the power of 1 over t. Okay, almost done. Something should be looking pretty familiar here. We have a variable approaching 0, so that t approaching 0 plus 1 to the power of 1 over t. Here we have a variable approaching 0, z, plus 1 to the power of 1 over z. This right here is where we're doing this limit thing. So even though the natural log is happening outside of it, if we're looking at what's actually happening to t, it's approaching 0, being added to 1, and being brought to this power. We can replace this with e. This is right here our definition of e, and it's still going to be carried along with this natural log and the 1. But let's make that substitution. 1 over ln e. You might need to pause just to double check that that makes sense. This is where the limit is happening within the natural logarithm. So this will look the same as this definition for e. ln e is just 1. We get 1 over 1, which equals 1. And there is what our limit evaluates to. So hopefully that was useful.